Okay, today we're looking at chapter 5 in the math textbook, which is sequences and series. So in this chapter there are 4 subtopics: the arithmetic sequence, the geometric sequence, the arithmetic series, and the finite geometric series. So right now we'll look at the arithmetic sequence. So these two are arithmetic sequences because if you look, an arithmetic sequence is when in a sequence the common difference is the same. So here you can see we add 3, from 5 to 8 we add 3, and from 8 to 11 we add 3. So the common difference, we'll label that D, is 3. That means it's an arithmetic sequence because it keeps increasing by 3. This is also an arithmetic series because 30 to 25 is minus 5, 25 to 20 is minus 5, and 20 to 15 is also minus 5. So here the common difference is minus 5. There's a general formula for the arithmetic sequence, and that is un equals u1 plus n minus 1d, where d is the common difference, like we discussed, where it increases or decreases by the same amount. Un is the term you want to find, so term 100, let's say, then n would be 100. u1 is the first term, so in this case above, for this sequence, for this sequence, u1 would be 2, and then n minus 1, so let's say we're finding the 100th term, it'd be 100 minus 1. So that's basically the formula used for an arithmetic sequence. So let's look at example 1, where we consider the equation 2, 9, 16, 23, 30, and it goes on, it keeps going on. So show it's an arithmetic sequence. So to show it's an arithmetic sequence, we look at the common difference. So 2 to 9 is 7, 9 to 16 is also 7, 16 to 23 is 7, and 23 to 30 is 7. So the common difference is constant, it's at 7, therefore it's an arithmetic sequence. So part B, we have to find the general formula. So we'll just use this formula above and just substitute our values in. So I'll zoom out a bit, and now we see our formula is un, so that stays because that's what we're trying to find, the general term. u1, in this case it's 2, plus brackets n, so that stays at n, minus 1, and the common difference, which is 7. So that's our formula. For part C, we have to find the 100th term in the sequence. So to find that, we do u100 equals 2 plus 100 minus 1 times 7. So oh, okay.
What happened?
700 minus 7,
What did you do?
603 plus... No, it still works, don't worry. Oh shit, I forgot where I left off.
Yeah.
Okay, no, don't worry. So anyway, in this question, u100, this is the formula to find the 100th term. So then we just solve it. So it'll be 2 plus, we expand it, 700 minus 7, which equals 702 minus 7, which is 695. So the value for the 100th term is 695. And the last part D, to find if 828 is in the sequence, we'll let un equal 828. So now we plug that in. So 828 should equal 2 plus n minus 1 times 7. So we can 828 equals 2 plus 7n minus 1, which equals 7 minus 7, which equals 7n minus 5. So we can bring the 5 to the other side, which becomes plus 5. So 833 should equal 7n, and 833 divided by 7 should equal n, and n equals 119. So because n is a whole number, it is in the sequence. It's the 119th term. Now we'll move on to the geometric sequence. So geometric sequence is slightly different because an arithmetic sequence has the same difference. A geometric sequence has the same ratio. So we'll call this R, that's the ratio. So a geometric sequence will have the same ratio. So if you look at this one over here, number 1, it goes 2 to 10. And to find the ratio, you take the second term and divide it by the first term. So 10 over 2 equals 5. 50 over 10 also equals 5. And you can keep going take the last term and divide it by the term before that. So 250 divided by 50. So that also equals 5. So therefore, it's a geometric sequence because the common ratio is equal to 5 for all of them. And this one on the right hand side is also a geometric sequence because if we use the same method and do u2 over u1, so u2, u1, u3, we'll get minus 10 over 2, which equals minus 5. We'll get 50 over minus 10, which is also minus 5, and minus 250 over 50, which is still minus 5. So this is also a geometric sequence. The common ratio is negative 5. So this is a general formula for the geometric sequence. So R is the ratio. So you can find that by un over un minus 1. And then u1 is the first term. We already went through this. Un is the term you want to find. And n minus 1, n we know is the term you want to find. That term number. So if we look at example 2, we'll consider this 8, 4, 2, 1 and half, and we'll prove it's geometric first of all. That's not good. Okay. Oh.
Okay, edit this part out as well.
Yeah.
I was about to sneeze in one of my ones.
I should have held my nose. Okay. But we'll prove this is a geometric sequence now because we'll do u2 minus u1, so 4 over 8, that's a half. 2 over 4, that's a half. 1 over 2, that's a half. So we know the ratio is half for all of them. Therefore, it's a geometric sequence. Now for part B, find the general formula. So we'll just, copy from up here. So un stays the same because we don't know what we're trying to find, equals u1. The first term is 8. The ratio is half, so we'll do half and then minus 1. So that stays the same. And lastly, find the 12th term. So to do this, you have to find the 12th term. So we'll just substitute 12 into all the n's. So 12 equals 8, or un, we have to find the 12th term. So n is the term, so un, we have to find the value, equals 8 times half to the power 12 minus 1. So un should equal 8 times half, 8 times half to the power 11. So you can put this in the calculator and you should get 1 over 256. So that's the value of the 12th term. Now we'll move on to the arithmetic series. So the difference between a series and a sequence is that a series is added, whereas a sequence is just commas instead. So you can see the additions keep coming up, so that means it's a series. But it has the same principle. It has to keep increasing by the same amount. So this is still plus 2, this is still plus 2, this is still plus 2, and it keeps going to 49. So there are 2 equations and 2 formulas to use for an arithmetic series. So you have the first one, which is Sn, so S stands for sum. Sn, so the n number of term, n over 2, u1 plus un. Or you can use the alternative, which is Sn equals n over 2, 2un plus n minus 1 and d. So this one we can see we have the common difference. And other than that, they're quite similar in the terms of we have u1, which is the first term, n over 2, so n is the number of term you want to find, so that value, Sn, and then n we already know is the number of term. So that's all we really need to know for the equation. So we look at this example where we have to find the sum of this series 4 plus 7 plus 10 plus 13, and it keeps going to 50 terms. So to solve this, we'll have to find out a few things. So u1 we know is 4, so we'll write that down. We know the common difference is 3, because it increases by 3 each term. 10 to 13 is plus 3. And we know n equals 50, because that's what we want to find. So now we can look up and see what formulas we have. So we can use the second one because we have d u1. You'd use this first one over here if you know the value of the 50th term, but in this case we don't. So we'll use the second equation. Sn equals n over 2 brackets 2u1 plus n minus 1 times d. So Sn we have to find, so sum of the 50 terms equals 50 over 2 times 2u1, so that's 2 times 4, plus 50 minus 1 times the common difference, which is 3. So we can simplify this. 25 times 8 plus 49 times 3. So when we put this into a calculator, we get the value of 3875. So that's the value of the sum of the first 50 terms. The final part of this chapter will be looking at finite geometric series. So here we can see what a sequence will look like. Like I said previously, it has commas, so this makes it a sequence, whereas the addition signs make it a series. And like I said, they have to have the same ratio each time. That's how you know it's a series. So geometric. So 2 over 1 is 2, 4 over 2 is 2, 8 over 4 is 2. So this is a geometric series because they have the same R. So this is how you'd find, this is what, if you had no numbers, this is what a geometric series would look like. You'd have the first term times the ratio, first term times the ratio squared, and that keeps going until the last term. So like the arithmetic series, we have two equations. We have Sn equals u1 brackets r to the power n minus 1 over r minus 1, or it's the same except the denominator is 1 minus r instead of r minus 1. So you'll use this one mainly if r is greater than 1, and you'll use this one if it's less than 1. If r is less than 1. Yeah, and so I made a mistake. So when r is greater than 1, you'll use this left one. And like the same, this is the ratio still. This is still the first term. Sn is the sum of n terms. N is the number of terms you want to find. So yeah, so now we'll use this example and the two formulas and answer the example 4. So we have to find the sum of 2 plus 6 plus 8 plus 54 all the way to the 12th term. So first let's write down what we know. So the first term equals 2. The ratio is 6 over 2, which is 3. And just to double check, we'll do it for the second and third term. So it'll be 18 over 6, which is 3, and 54 over 18, which is also 3. So now we know the ratio is 3, and n, we know n is the 12th because of the 12 terms. That's what we have to find. So now we know the common ratio is 3. We'll use this equation on the left because r is greater than 1. So s of 12 equals 2 times r, we know r is 3, to the power n, in this case is 12, minus 1, over r minus 1. So r3 minus 1. So we can simplify this to 2 times 3 to the power 12 minus 1 over 2. And you can just put this into your calculator and you'll get the value of 531,440. So that is the sum for the first 12 terms. And yeah, that's all you need to know about sequences and series, and that's all you get tested on.